Another problem for projectile motion, problem 70. Here we have this projectile which we are launching it with initial velocity of 200 meters per second with 60 degrees from the horizontal direction. So it's gonna go up and gradually come down because of gravity and hit this incline. And the question is, what's gonna be the range? What's gonna be the distance between A and B? So again, think about this problem yourself for 10 minutes, then see the rest of the video. As always, I'm gonna start with my coordinate, defining my coordinate, and you should do that always. So this is gonna be my coordinates, X and Y. X is horizontal direction, Y is perpendicular direction. And because we are talking about displacement, then again, naturally, I'm gonna use those two displacement equations. So X is gonna be equal to x0, which is 0, plus initial velocity in the x direction times t. Initial velocity is gonna be 200 times cosine of 60. 200 times cosine of 60 times t. And there is no acceleration in the x direction. Cosine of 60 is 1/2, so x is gonna be 100 times t. And for y direction, y is y0, which is 0, plus initial velocity in the x direction, which is 200 times sine of theta, sine of 60, times t, plus 1/2 of acceleration in the y direction times t squared. So it's going to be negative 1/2 of g, which is 9.81, times t squared. So these are my equations for the location of this projectile, right? My point of interest is this point. Let's say it is hitting point B at time tb. And x and y of this point are going to be r times cosine of 20 and r times sine of 20, right? So at point B, we are going to have x of point B is the range, which is unknown, times cosine of 20. So r times cosine of 20 is going to be equal to 100 times t. So 100 times tb, the time which it hits point B. And same thing for the other equation, y of this point is r times sine of 20. R times sine of 20 is equal to 200 times sine of 60, which is 173.2, times t, which is going to be tb here, minus 1/2 of g, which is let's just write it, 9.81 divided by 2, times tb squared. Now look at these two equations. Let's see how many unknowns we have here. Unknowns are r, right? We don't know what is r, we are looking for it. And also we have tb as other unknown. We have two unknowns and two equations. So mathematically, it should be possible to solve this problem. So to solve this problem, probably the easiest way is finding tb from the first equation in terms of r and replacing it here. So we are going to have everything in terms of r. So from the first equation, tb is going to be equal to cosine of 20 divided by 100, which is going to be 0.0094 times r. Now if I plug that tb in the second equation, I'm going to have a quadratic equation for r. So r times sine of 20 is going to be equal to 173.2 times tb, which is 0.0094 times r, minus 9.81 divided by 2 times tb squared, which is 0.0094 times r squared. And of course, this is a quadratic equation, and one of the solution is trivial. R can be equal to 0, right? So if you separate that solution, you can cancel out r from both sides of the equation and have only a linear equation for r. So it is quite easy to solve this problem. So r is going to be equal to, we're going to have two solutions, 0 and also 2970 meter. And of course, this is going to be the acceptable solution. And the physical meaning of the other solution means the first time that this ball, this projectile is hitting this incline, which is point A. So it's gonna hit this, it's gonna be in contact with this incline twice at point A and point B. Point A time is equal to 0 and r is equal to 0. At point B, TB is gonna be 0.0094 times this number, which I did and calculated, and r is gonna be 2970.